All right, cancer is the second leading cause of death in the United States. This generally stems from the fact that cancer is mutated cells from the host, and the immune system does not recognize it as a foreign being. These mutations also allow for altered metabolism within the cancer cells that allow them to upregulate several enzymes, including alpha-mannose-sidase, beta-galactosidase, as well as several different nitroreductases. In the past, immunostimulants have been used in order to elicit anti-cancer immune responses. However, with several of these immunostimulants, including the FDA-approved anti-cancer immunostimulant imiquimod, systemic toxicity was observed during intravenous injection. This is despite the fact that several immunostimulants have shown very promising anti-cancer immune responses in vivo and in vitro. This strictly limits any and all immunostimulants for anti-cancer therapy to topical application in order to fight basal skin cell carcinomas. One method of targeting different cancer drugs is the use of directed enzymatic prodrug therapy, in which a very toxic drug is caged with an enzyme cleavable cage. This cage then enters the enzyme-enriched tumor microenvironment, which ultimately releases the enzyme cleavable cage, allowing for the cytotoxic drug to be activated localized within the tumor microenvironment. This targeting strategy does have a very serious side effect, and that is called the bystander effect. In the bystander effect, the toxic drug is activated by one cell and it diffuses away and interacts with and kills a nearby non-cancerous cell. You can imagine that this allows for off-target toxicity and causes very serious side effects by killing the surrounding tissue. In this study, we proposed ultimately combining the enzyme-directed effects with immunostimulants in order to allow for enzyme-directed immunostimulants. In this, essentially, you cage the critical moiety of your immunostimulant with an enzyme cleavable cage. In the absence of any of the enzymes in the tumor microenvironment, the immunostimulant remains caged and you see ultimately no immune responses, thus mitigating the off-target cytotoxicity. However, in the presence of the enzyme-enriched tumor microenvironment, the enzyme cleavable cage is removed and allows you to selectively target immune cell activation localized within the site of the cancer. This allows us to take advantage of the bystander effect because we intend that the pro-immunostimulant would be activated by one cell, diffuse away from the tumor microenvironment, and activate nearby surrounding immune cells in order to elicit an anti-cancer immune response. This also prevents the systemic toxicity that has been observed from circulating immunostimulants throughout the immune system. In this work, we would target enzymes that are commonly upregulated in tumor microenvironments, including alpha-mannose-sidase, beta-galactosidase, and nitroreductase in order to take advantage of those enzymes.